Hi ladies and gentlemen, so today we're taking a look at 4.5 exponential equations. So in the warm-up, we're just reviewing some of the things we learned about in 4.4. So the first is to evaluate log base 10 of 2 plus log base 10 of 50. As we talked about in 4.4, when we are adding two logarithms with the same base, we can combine them together using multiplication. So this will become log base 10 of the product of 2 and 50, which is 100. The answer to that, or 10 to what power is 100, is 2. Looking at the next one, log base 6 of 36 to the power of 12. We begin evaluating this by taking that exponent of 12 and bringing it to the front and multiplying it by the log base 6 of 36. Then we evaluate log base 6 of 36, which is 2. We multiply that 2 by the 12 to give us the final answer of 24. So today's objective is to solve exponential equations. This is some of my favorite types of problems to do because it's one great big puzzle and it's just so cool to be able to see how the numbers work together to be able to solve these really intricate problems. There's two very important properties of how we're going to be able to solve these problems. The first is that if your base of the exponents is the same, you can drop the base out and set just the exponents equal to each other. The second is if you have some number equals another, you can take the logarithm of both sides. Remember, logarithm is an operation. So very similar to if I have an equation and I multiply both sides by 3 to keep it equal, I can do the exact same thing with logarithms. They are operations just like multiplication or square rooting both sides or adding a number to both sides of your equation. As long as you stay consistent and whatever you do to one side, you do to the other, you'll be all good to go. So these are going to be your kind of two ways to get started with the problem. Either you're going to take the logarithm of both sides, or you're going to get things into exponential form to be the same base. All right, so let's get started. So example 1, we are going to solve for x. We have 7 to the power of 2x equals 7 to the power of 4. Notice that this is like that very first property on that last slide. Our bases are both 7. So when solving, if the bases are already the same, really what we're going to focus our attention on to be equal are the exponents. So 2x equals 4. This becomes very easy to solve for x. We divide by 2, and we get x is equal to 2. And you might be like, Mrs. Walker, did I really have to show work for that one? They're not all going to be this easy. This is just the start. All right, example 2. I told you it was going to get more challenging. We have 3 to the power of x plus 1 equals 9 to the power of 2x plus 14. They don't have the same base anymore. But we can make them have the same base. That's the really awesome thing about numbers is that you can have a number represent the same value but look different. So for example, 9 can still be 9, but it can be written looking like a 3. And you're like, whoa, that's really confusing. This is what I mean. 9 is the same thing as 3 squared. So originally I had 9 to this exponent of 2x plus 14. Well, I've replaced 9 to have a base of 3 because I've rewritten 9 to be 3 squared. So that 3 squared has an exponent of the original setup of the problem, 2x plus 14. The other side of the problem doesn't need to change at all because it already has a base of 3. So notice, now my bases match. Pretty cool. I think it is. So from here, if you think about what we have going on the right side of this, we have 3 to the power of 2, which is then to the power of 2x plus 14. So we have this double power going on. And when you have that, you need to do a little bit of simplifying. And so this 2 needs multiplied by all the pieces outside of the parentheses. So that's going to end up giving me 3 to a power of 4x plus 28. And then the other side is going to stay the same. So 3 to the power of x plus 1. Now my bases match, and now I can drop that base of 3 out, and really my focus is going to be on setting the x plus 1 equal to the 4x plus 28. And I can begin solving for x. I'm going to subtract x over and subtract 28 to give me negative 27 equals 3x, and divide by 3. And I get an answer of negative 9 equals x. And the really beautiful thing about this is you can check your work. You can take negative 9 and plug it in for x on the left and right side of the original problem, and you should get the same number equal to itself when you do that. All right, let's do one more. That's like this, and then we'll move on to another type of problem. Example 3 is just like example 2. So I take a moment to pause the video and give this a try on your own, then press play to see the answer. All right, so hopefully you were able to figure it out. If not, hopefully this explanation will help then. So I have 4 to the power of 2x equals 2 to the power of 3x plus 9. Now, a very common question I get every single year is, Mrs. Walker, can't I just multiply the right side by 2? Well, if you did that, you'd have to multiply the other side as well, and that doesn't help you. Some students say, well, Mrs. Walker, can't I raise the right side to the power of 2? Because 2 to the power of 2 is 4? And the answer is yes. You would then just have to do it to the other side as well, and that's okay. So what I mean by that is if some of you were looking at this and you thought, okay, well, what if I just square the 2? That's going to give me 4. And you're right, it does. But if you're going to square the 2, you also have to square the left side. So if you're going to add in a power of 2 on the right side, you have to add in a power of 2 on the left side as well. Remember, the goal here is to get the same base. So what would we would do if you use this method is you would have 4 to the power of 4x, because you would take the product of 2x and 2, and that would give us this 4x. On the other side, you're not going to multiply that exponent out. You're going to actually apply the exponent to the 2 to give us a base of 4, and then we would still have this 3x plus 9. From here, you would set the 4x equal to the 3x plus 9, subtract the 3x, and that would give you x equals 9. And if you did it the other way, very similar to what I did in example 2, and you change the 4 to be 2 squared, you will notice that you're actually going to end up with the exact same thing.